Okay, so we're going to be solving for a solid cylinder about its central axis. So the formula for that is mr squared over 4 plus ml squared over 12. So this part is rather straightforward. We're just solving for the length. I'll show you how to do that later, but this part is what we're really looking for. So we're going to be we're going to be trying to find the mass, and we're going to be trying to see how radius comes to play and all that other stuff. So density that's the formula that we're using. So density is equal to mass over volume. So we're going to have to figure out what volume is. So volume in this case should be equal to the face of the cylinder, which should be pi r squared times the length. So this gives us m over v times pi r squared times length. So what we're going to do is we're just going to plug this in. And so volume is mass over volume, and so volume's equal to pi r squared times dz. This is the thickness of the disk. It's the same as length technically. So we have m over pi r squared times length times pi r squared times dz. These cancel out, so now we have m over L times dz. And so this is going to be number 1, I guess. We know that the moment of inertia of a circular disk of mass m and of radius r are about its central axis. This is the same as for a cylinder of mass m and a radius r, given by the equation I z is equal to 1/2 m r squared. This is what we have, but usually it's going to be diz is equal to 1/2 dm r squared. So these are gonna be our equation 2's. I'm gonna use this one. So the moment of inertia about an axis which is perpendicular to the plane contained by the remaining 2 axes is the sum of the moments of inertia about these 2 perpendicular axes through the same point in the plane of the object. It follows that diz is equal to dix plus diy. This is our equation 3. Also for symmetry, we see that the moment of inertia about x-axis must be the same as moment of inertia about y-axis. So that means that dix is equal to diy. This is going to be our 4th equation. Now, if we combine the equations 3 and 4, we'll get something like dix is equal to diz over 2. If we substitute iz from equation 2, then we're going to get something that is like this. So it's going to be dix is equal to 1/2 mr squared over 2. So in order to find the 1/4, we can factor this out. So I'm just gonna get rid of mr. This will just go somewhere else. We'll bring that back in later. So we're gonna have dix is equal to 1 over 2 over 2. So we're gonna have to find the reciprocal. So 2 over 2. You're gonna take 2 over 2 and you're gonna flip that, which is the exact same thing. And so you get 4. Oh, never mind. This is wrong. It's going to be like dix is equal to 1 over 2 over 2. And so you can take the reciprocal of this. It's one of these. And then you're going to multiply it. So this is going to give you 2 over 1. So, oh no, I messed up again. Ignore me. So you're going to get 1 over 2, which is just 1/2. So 1/2 times 1/2 is going to be equal to 1/4. I'm going to do this on a sheet of paper. So you are going to get dix is equal to 1/4. We're bringing back the dmr squared, so dmr squared. So now we are going to solve for the I part. Well, I is equal to ml squared over 12, part of the equation. So okay, so in order to find 1 over 12 ml squared, we are going to get the integral. So our limits are going to be L over 2 to negative L over 2. We are going to have m over L outside of the integral, and we are going to be integrating x squared times dm. So this becomes m over L over 2, negative L over 2, x to the third over 3 times dm. Now we take this down and we are going to plug in our limits. And so this gives us m over L times L over 2 cubed over 3 minus negative L over 2 cubed over 3. In order to get rid of these denominators, what we're going to do is we're going to do the exact same thing that we did before, but first we're going to have to cube the first denominator. So 2 times 2 is equal to 4, and 4 times 2 is equal to 8. And 8 times 3 is equal to 24. So that means that we have L over 2. Oh, actually, no. We have L cubed over 24 minus negative L cubed over 24. We can combine these now. So because there are two negative signs on either side of this parentheses, you just turn this into a plus sign. Just kind of like put these together. So this is a plus sign. And so you get 2L cubed over 24. ML still on the outside. Okay, so because there's an L here and there's an L here, we can cancel them out. So we cross that out and we cross that out. So this means that we have M times 2L. Times 2L squared over 24. We can simplify this further, and so what we're gonna do is we're just gonna divide 24 by 2. So we have L squared over 12 and times m, and so this can be simplified further to 1 over 12 times ml squared. So if we put both these together, that means that we will have 1 over 4. Let me look again. We are going to have 1/4 dmr squared, which is the same as 1 over 4 mr squared plus what we just solved for, 1 over 12 ml squared. So that's how you get the solid cylinder about its central axis formula.